Thank you for Chairman Inatomi-san Sensei. I'm Hiroshi Nagaoka from Ritsumeikan Universities. I have joined in Japanese lunar exploration missions, Serene and Surin. Before my presentations, Professor Morota-san talked about science objectives and target sample to return in order to access a big pictures of planetary science. I will focus on in-situ analysis to return important sample using pressurized rovers. Thank you. Next slide, please. First of my talk, I will repeat what the Morota-san talked. We have big picture to investigate the moon. One is the understanding impact history of early solar systems. Reconstruction of impact history in the early solar system and verification of the late heavy bombardment hypothesis associated with giant planet migration model is aimed by return impact melt rocks from Nectaris and SPA basin. The other is understanding bulk composition of the moon and its origins, including the giant impact and lunar magma ocean and its differentiation process. Constraints on the lunar formation condition leading the origin of Earth-Moon system by verifying the lunar magma ocean models. By returning primordial crust rock, PAN, from outcrop exposed at central peak of JAXA crater and shooting basins. Next slide, please. Our science theme matches understanding planetary process and understanding characters and origin of lunar polar volatile and interpreting the impact history.
Nagaoka-san, we cannot hear you talking.
Looks like we might have lost his connection for a moment.
Okay.
Go ahead. I think we have you back now.
All right. Nagaoka-san, go ahead, please.
Okay. Sorry, I saw the previous slide. So
next slide, please.
Next slide. Yes, next slide, please. Thank you. In this activity, we searched a good sampling site of the primordial cluster rock and impact melt rock. In this slide, appropriate sampling site of the primitive cluster rock is identified around central peak in Jackson crater, located on central far side highland with remote sensing data. They are exposed on rough terrain near steep slope and boulders, dense areas around craters as pointed by yellow arrow in the right figures. It is important to access fresh rock released from the outcrops identified by remote sensing data and bring back the samples. So when exploring the area, it needs the pinpoint landing techniques and mobility techniques on rough terrain and robotics techniques for sampling, handling, and selection on the moon. Pinpoint landing technique has been successfully demonstrated by SRIM last year. So for next step, it is important to demonstrate mobility technique and robotic techniques for sampling handling and sample handling and selections. Thank you. Next slide, please.
Nagaoka-san, again, your connection is stopped. Yeah.
Okay.
We may miss your talking a little bit, so please start the explanation of this slide.
Okay. Sampling site of this slide shows the sampling site of impact melt rock identified at the fresh crater around Nectaris basin as the right figures here. Their rock also exposed at steep slopes and boulder dense areas. So also same technology is required for this sampling for return samples. Thank you. And next slide, please. We can identify the fresh large boulders more than a few meters exposed from the outcrops with
Nagaoka-san, again, your connection is stopped. Ricky-san, what happened on the his talking? I'm not sure the connection network condition is not so good. I think so.
Yeah, I still see that he's in my list of the participants,
Hmm.
but his video is
I-
gone. I do see his microphone is still on.
Hmm.
If he comes back, we could try without video. That help.
Yeah, we can do that.
Actually, I can hear you. Ricky-san talk is clearly. I can hear you. So it might be the problem of the network from Ritsumeikan University to this website, WebEx system.
Can
sorry, my network is down. Sorry. Can you hear me?
Okay, I can hear you.
I connect the other network, so sorry.
Start this from this
Okay.
seat.
Sorry, the firstly I have started. We can identify the fresh large boulder more than a few meters exposed from the outcrop with the remote sensing data. However, we cannot return 4 of them to the Earth. They are much large. So it needed in-situ analysis instrument to determine whether this large boulder is a sample which we need. So next slide, please. In this slide, the required engineering and scientific techniques are summarized for the sample handling and for in-situ analysis. So next, please. Especially for wide area observations, the heritage of multi-band camera on board SLIM is very useful to search targets. Right figure shows a lunar surface observation by SLIM multi-band camera. So SLIM is very useful to search target rocks by using multiple wavelength band imaging corresponding mineral absorption, as discussing in Nakauchi-san's talk yesterday. Thank you. Next slide, please. In this slide, I introduce in-situ analysis to develop for sample return missions and sample selections on-site. Gamma ray and neutron detectors Momotaro presented by Enoto-san for measure water and elements abundance to map yesterday. And microscopic hyperimager camera presented by Nakauchi-san for observing mineral textures and compositions. And LIBS, laser-induced breakdown spectroscopy, LIBS measures elemental abundance in rock and regolith. Cho-san presents the development of LIBS after this session. Thank you. Next slide, please. This exploration scheme to return sample. The search for the target rocks can be divided into observation phase, cause, and detailed observation. For cause observation, first is the wide-angle distribution of the rock and elements and are obtained using data of wide-angle IR camera and long-range LIBS. angle camera use multiple wavelength bands sensitive to mineral absorption to identify target. And based on its observation, rover approaches the target boulder and leaves measures the elemental composition to cite the compositional heterogeneity. During the moving and approaching, Morota rods measure water and elemental distribution to connect ground truth data on site. Based on the result by previous causal observation, we determined whether the detailed observation by microscopic hyperimager camera and Raman spectroscopy are leaves. In the case of the pan, the necessary evaluation criteria to judge whether the sample is pan and whether the sample are to observe high plagioclase abundance and mineral texture. Microscopic IR hyperimager and Raman spectroscopy and short-range leaves are used then. A compact Raman spectrometer was developed to the rover of the MMX mission, so we plan to advantage and this heritage. Next slide, please. This slide shows the roadmap of sample return to low altitude regions. First, pressurized rover will land on lunar South Pole. We expect a technology demonstration of in-situ instrument and determine the elemental composition of polar crustal rock and exploration of impact-made rock from the SPA. Next, please. Next, please. Next. Thank you. Utilizing the heritage and gain there, we aim to reach pristine old rock exposure in low altitude region, Jackson and Nectaris, and return a primordial crustal rock and impact melt. Thank you. Next slide, please. This is a summary of my presentations. That's all. Thank you very much.